Okay, just a minute because my laptop is heating. That's why I'm not able to. So here we have, okay. So in this case, if I'm talking about, is I'm audible to you, Samia?
Yes, sir. Yes.
Okay.
Yes, sir.
Siddharth, Anas, oh. So let's start. So if I'm saying that solids, the particles are very close to each other, and liquids particles are separate, and gases are their particles are very much separated. So if I'm just talking about the properties of solid, the solids solids if I'm talking about the characteristics of particles of solids, the solids have definite shape. You know that they have definite shape, definite shape, definite shape. Okay, the particles are very tightly packed to each other. Okay, why they have different shape? Because they have very less amount of kinetic energy between their particles. So particles are not able to move freely. Okay, so particles stick at one position. That's why we'll simply say here that they have definite shape. Okay, they have fixed volume. They have fixed volume. They are incompressible. They are incompressible. They are incompressible. Okay, note it down.
Okay.
Okay, done. Noted. So if I talk
Yes,
about
sir.
that, this one, the solids have different shape, they have different boundaries. Okay, if I'm talking about that, they are rigid. They are rigid. They are rigid and are incompressible. Okay, they are incompressible. So if a question comes in examination that we know that solids are rigid and incompressible, they have low income means we will say that they are incompressible. So if the question comes in examination that why do actually if I'm talking about uh the sponges, okay, sponges, you know that in sponges, if we take a sponge and if we press it, so you can press it. Okay, so why the sponges are going to press? Why we it's still, you know, the sponge is solid. Okay, it has fixed shape. If you kept it okay, under stir, so it has fixed shape, it will not change its shape like the water. Okay, if you even if you kept the sponge anywhere, like if you kept it on the table, if you kept it in the, it will have its shape. Okay, but it is
Yes.
compressible. Why it can be compressed? Can you tell me
So
why?
since it has small holes and pores, that's why
Yes.
the matters get spaces to move.
Okay, okay. So we'll simply say that because you know that sponges are going to have intermolecular space. Sorry, not the intermolecular space. We'll saying that, let's suppose it's a sponge, okay, and this is going to have a small holes inside it, okay, and because the small holes are present here, and air is trapped inside it, okay, air is trapped inside it. You can check it here. This is air, and this air is particle. So when you press it, the air comes out from the sponges. Okay, the air rushes out, and because of that, we will simply say that they are they are compressible. Okay, so sponges are compressible because air is present inside it. So note it down. Write a question in your copy that why sponges are compressible, still they are solid. Why sponge is compressible, still it is solid. Still it is solid. Done? Noted?
Yes, sir.
Yes,
Okay.
sir.
Yes, sir.
Okay. So here, if I wrote it down here, so what's the reason behind it? So you can write it. We can compress the sponge as it pores are filled with air. Okay. Note it down up to here. As it pores are filled with air,
Okay.
we can compress the sponge as its pores are filled with air, and write further that I'm dictating up to here. Have you noted up to here?
Yes, sir.
Yes, sir.
Okay. Then
Yes,
write
sir.
the further statement. I'm just writing it for you. Filled with air, and when we compress it, and when we press it, and when we press it, and when we press it, okay, and when we press it, the air from these holes rushes out, rushes out, and and the sponge particles or material take that space, take take that space, take that space. Done? Noted?
Yes, sir.
Yes,
Yes,
sir.
sir.
And if I ask you a simple question, that why do rubber bands? Rubber band. I'm saying that rubber bands are incompressible. I'm saying things solids are incompressible. Okay. So why do rubber bands are able to? Why we are able to press means express the rubber band expand? Why rubber band can expand and change shape? So we are saying that like solids have definite shape. So if solids are going to have definite shapes, and if we are able to expand the rubber band, then rubber band can expand. It can change its shape. Why?
So since rubber band has the property of elasticity.
Okay. Do all substances are elastic? Do you think that? What do you
No,
mean by
sir.
that? What do you mean by the elastic and plastic in terms of physics? In terms of physics, elastic substances are those substances that are not compressibles. That are that are compressible. They are called elastics. Okay. Like for example, if your phone is fallen, okay, if your phone is fallen, then it hits the ground. Okay, and when it hits the ground, actually the corners items hit the ground, and they get a rebounding, okay, force that make it move upward. Okay, so do you think that if you are taking a ball or an iron ball, will it stick on the surface of the, will it bounce back or not? Will it bounce or not? If you are just dropping a phone or something, like if you are means a solid substance, these generally they are just plastics, sorry, they are elastics. But just imagine that you are having a dough. Okay, a dough means from which you make the bread. Okay, and if you fall it on the ground, it will stick on the ground, it will not bounce back, so it is plastic. In terms of physics, it is considered to be as plastic. So we say that solids, when strike on the surface, they got a bouncing back features. Okay, but this force is different in different materials. Like if I'm talking about the rubber bands, okay, rubber bands, if you apply the force, their particles get stretched. Okay, they are not breaking. The rubber band break after a large amount of force is applied. Okay, But when you release the force, it regains its shapes. Why it is? Because the particles are attracting each other. Okay. Okay. You got
Yes,
it?
sir.
So if the
Yes,
question
sir.
comes in your examinations that
Yes, sir.
why do rubber band is solids, okay, and still if the rubber band is solid, then why it is plasticable? So note it down. Rubber bands are solid because it can change its shape under the force and regain its shapes when force is removed. Force is If the excessive force is applied, it breaks. Done?
Yes, sir.
Done, everybody?
Yes, sir.
Yes, sir.
Anam, you done?
Yes, sir.
Okay. So if I'm asking here, if a question comes in your examinations, one more question comes in your examination, okay, and that is, if I'm talking about the salt, okay, salts, you know that solids are rigid. They are having the fixed shape, okay. You know, everybody, that if you are seeing a table lamp on your desk, then it will remain as a table lamp. It will not change its shape. A screen, a monitor, a computer screen will have the same shape. But if I'm saying that the salt and the sugars, okay, if you are just keeping the sugar in a vessel, like it is a shape of, means a spherical shape vessel. So if you pour the sugar or salt in that one, it will take the shape of that one. For example, if I'm having a container like this, okay, if I'm having a container like in this shape, okay. So, and if I'm pour the sugar into it, so it will fill like this shape. Okay. And if I'm having a spherical container, if I pour the sugar in this one, then it will going to have this shape. So why we are saying that that solid have fixed shapes? Solids have fixed shape. Then why do the sugar and their salts kept in the container take the shape of that salt of that vessel? Why do they are taking the shapes? Can you tell me?
So, since the sugar or the salt crystals are so small that they act as the molecules of a solid and remain closely packed and takes the shape of the container.
Yeah, we will simply say that here the particles are small, okay, and because the particles are small, so it does not mean that the crystal particle does not change its shape. So if the crystal is cubical, so it will remain. If I'm saying that this is a crystal and which is a solid, it is a small piece, okay. So as a whole, I'm not talking about. As a whole, we are not talking about, okay. We are talking about the crystal. The crystal size or shape will not change. So if the crystal is small and it is a small cubical structure, so the cubical structure of the crystal will remain same. It is not going to change. So we are talking about the shape of the crystals, not the shape of the all the together the shape of all the crystals. No. Okay. So here noted down this point also. Note this point also. That salt and sugar take the shape of the container in which they are placed, but okay, are placed, but the shape of the crystal do not change. So they are solids.
Done, sir.
Sir, done.
Sir, done.
Samya, you done?
Yes, sir.
Okay. So if I'm talking about further, Okay, now talking about the liquids. So the three type of questions comes in examination on the solids or the characteristics of solids. The first is sponge, second is rubber band, and the third one is the salts. Okay, if we are just keeping the salts in a container, then it take the shape of the. We are not talking about the shape of the as a whole crystals. They are making the shape. We are just talking about the shape of single crystal. The single crystal shape does not change. So IE, you write it. So they are solids. IE, you can write it one more further. That is IE. Add further IE. IE. The shape of single crystal will remain same. Will remain same. And write more one more point here. Will remain same. Noted? Will remain same.
Yes, sir.
Yes, sir.
Okay. Note it down further. I the shape of single crystal will remain same. As a whole, as a whole, as a whole, the arrangement of small crystals, crystals take the shape, take the shape of the container as they are very small in size. They are very small in size. Okay, you understood?
Yes, sir.
Noted? Okay.
Yes, sir. Yes, sir.
Now coming to the next part here, towards the liquid. So if I'm talking about the liquids, so here, liquids. Okay. So you know that liquids are means the matter, or you can say the state of matter, in which the particles have more kinetic energy, enough kinetic energy that they can move from one place to another place. Okay. Means they have enough energy. The energy is so enough that it can move from one position to another position. But in case of liquid, the particles kinetic energy is very less, so that they cannot move from one place to another place. Okay, you understood? So here,
Yes.
Yes.
if I'm talking about this one, so you have to note it down that the characteristics of particles of liquid state is that they are fluid. Fluid means either they can flow. They have fluid, they can flow. The particle can flow from one place to another. Okay, they are not rigid. They are not rigid. They are low. They have low compressibility. Okay, they have low compressibility, no definite shape and boundaries. So liquids, solids have distinct boundaries. What do you mean by the word solids have distinct boundaries? Just wait a minute. Just you concentrate here. If I'm saying that solids have distinct boundaries, what do you mean by the word distinct boundaries? Can anybody in the class can explain me? What do you mean by the solids have distinct boundaries?
So the solids have definite shape and volume along with
Definite shape and volume is okay. We have written here definite shape and definite volume. But what do you mean by the distinct boundaries?
Said a real or an imagined line that marks the edge of an limit.
Exactly, it is correct. So anybody in the class can tell me that what do you mean by the word distinct boundaries? Anam, can you explain me this? Anam, are you there? Anam,
Yes, sir.
can you explain me that solids have distinct boundaries?
Mm, Sir, actually, we can say that solids have distinct boundaries.
Yeah, for example, let me explain you that. For example, if you are just watching television, okay, if the lights are turned on, okay, and if I ask you that where is the television, so you can say that in that corner this is the television. If I ask you that uh where is the refrigerator, so you can say that there is a refrigerator, there is an oven. So why? Because they have limited boundaries. Okay, so boundaries means the area where they are occupying that position. Okay. Okay. And if I'm saying that where is the refrigerator, so the place where the refrigerator is put in, you can say that this is the refrigerator. Okay. The place where there is no refrigerator, you can't say there is a refrigerator. Okay. So solids have distinct boundaries, means they are going to have boundaries. The table has boundary. Up to here it is table. After this, if after this area, there is no table. Okay. So that is a particular area in which the table is placed. Okay. So you can say that they are going to have boundaries. Boundaries, like for example, if I'm having a table here, so this is the boundary of the table. This is the boundary of the table. It has some length and breadth. But water does not have any boundary. Liquid don't have any boundary. They need a vessel in which they need to be kept. Okay, they don't have any boundaries. You understood now, everybody in the class? So in the
Yes, sir.
characteristics of solid,
Yes.
mark this point that solids have distinct boundaries. Mark this point that solid have distinct boundaries.
Done, sir.
Sir, done.
Okay. So write down the characteristics of particles of liquids, that liquids have no definite shape and boundaries. They take the shape of the vessels in which they are kept. Write a question: why do liquids have why do liquids have definite shape, definite volume? What do you mean by the word volume? Can anybody in the class explain me what do you mean by the word volume? Volume. Yes, Samia, what do you mean by the word volume?
Sir, could I tell?
Yeah.
So the quantity,
Yeah, speak. The quantity, yeah, you can say space. The
the
volume
space.
is the three-dimensional area that it is taking, that it is occupying. Okay, three-dimensional space that it is occupying. Okay. For example,
Yes.
if you kept a if you take a half-liter bottle, okay, or if you take a 1 liter water bottle, you have two bottles, 1 liter water, and you have two bottles. One is half-liter, another one is 2 liter. Okay. Can you fill the whole 1 liter water in the half-liter bottle? Whole 1 liter water in the half-liter bottle, it is possible to fill it? All 1 liter water in the half-liter bottle? No.
No, sir.
No, sir.
No, you can't fill it. Why? Because it has fixed volume. 1 liter water will occupy 1 liter space. Okay. It will not come in the half-liter. And similarly, if you pour the 1 liter of water, can you pour it into the 2 liter bottle? And will the 2 liter bottle will completely filled or not? If you are pouring 1 liter water in 2 liter bottle, will it fill it completely?
No, sir.
No, sir.
No,
No, it will
sir.
not fill it. Why? Because it has fixed volume. It will occupy the 1 liter space. Okay. And why it is doing so? Why it is not expanding? Like the gas can fill the container completely. Why do liquids do not? Because they have enough force of attraction between their particles. So they don't allow it to expand. Okay. So 1 liter water, it will remain as 1 liter water. It will not occupy the space of 2 liter bottle, or 2 liter space. It will not occupy because the force of attraction between the particles of the liquid is much enough that it will hold the particle together and will not allow it to expand. Okay. You understood?
Yes, sir.
Yes, sir.
So please note it down. The force of attraction between the particles of liquids keep its volume same. Note this point. The force of attraction between the particles of liquids keeps its volume same.
Done, sir.
Done,
Done?
sir. Yes, sir.
Okay. Next. Why do liquid don't have fixed shape? Can anybody tell me why do liquid don't have fixed shape? Why do liquid don't have fixed shape? Because
Says
the
the
particle.
particle
Yeah. Speak. Very
says the
good.
particles in the liquid state are not packed closely um, like the solids and are also arranged disorderly. That's why.
Yeah. Yeah, you are correct. But try to compress your answer in the proper words. Try to compress. Try to
So
give
the
some.
particles in the liquid state are not packed closely and also are arranged disorderly.
Yeah. Yeah, it is correct. And in terms of force of attraction and kinetic energy, if you need to use these words, then what you will write? Because the force of attraction between the particles of liquid is less as comparison to those solid, they are free to move. So they can move their space. They can, okay. So you can write it this one, or you can write the better word that you were using previously, that they have a space between them and they are arranged disorderly. Okay. So will you be able to write this answer?
Yes, sir.
And if I ask you that, why do the diffusion, you know, the intermixing of two substances without the semi-permeable membrane. Okay, so diffusion means mixing of something. Just concentrate here, diffusion. So why the gases are able to dissolve in the liquids? Just because, and why the solids are able to dissolve in the liquids? Because of the intermolecular space between them. Okay,
Yes, sir.
okay. So note it down.
Yes, sir.
Diffusion, note it down. That diffusion is much more in liquids due to free movement of particles of liquids. Diffusion is much more you done this one,
Yes, sir.
Yes, sir.
Yes, sir.
everyone? Samia and everybody,
Yes, sir.
you are just preparing notes or not?
Yes, sir.
Proper
Yes, sir.
notes. Anam, you?
Yes, sir.
Okay. Now talking about the gases. Gases, the characteristics of particles of gases, if I'm talking about here, so you can check it. The characteristic of particles of gases means they have fluidity. Fluidity means liquids, and so liquids can also flow because the particles are free to move. They have high kinetic energy. They can change their place. So fluidity means simply they can move from one place to another. So gases and liquids both have fluidity. They are called fluids. Gases and liquids are called fluids. Fluids. Okay. The characteristics of gaseous particles means they have fluidity. They are highly compressible. Why? Because they have large amount of space between them. So when you press it, they come closer to each other. Okay. So they have high compressibility. They have no definite boundaries. Why they don't have different boundaries? Because the particles do not attract each other. They're continuously moving. They don't live in a particular shape. They have no definite shape. They have no definite volume. Why do gases don't have definite volume?
So
Why do
since the intermolecular attraction is much more less than the solids and the liquids, that's why it has no definite shape or volume.
what do you say? Intermolecular space.
Space and attraction.
Yeah. We will say that we will simply say that they are going to have very less amount of space between them. And as a result of which, we'll simply say that when they are just making, means they are just having very less amount of intermolecular space. And sorry, they are just having the less amount of force of attraction between the particles, as a result of which the particles are very far away, separated from each other. So that's why we say that they don't have fixed volume. So simply, if I have a gas, 1 kg of gas, have you seen, you all of you have seen the LPG cylinder in your home?
Yes,
All of
sir.
you have seen, and that LPG cylinder is going to have, if I'm talking about, this is like this, okay,
Yes, sir.
and this LPG cylinder is going to have nozzle here, okay, one nozzle here. So why, if it is so, like you see that if this become empty, so the gas is filling up, day by day it is becoming empty, but the nozzle is always present at the top. Why don't the nozzle is present here at the bottom here? Why don't nozzle is not present here? Because you know that is, as the gas is means decreasing in this one, still the gas will fill the container completely. They have lot of space between them, so they keep on moving. Okay, so if day by day, if the gas is being removed from the cylinder, still the gas is keeping the container completely, it is filling the container completely. Why? Because particles are randomly moving and they strikes the wall of the container, and it is just, we'll say that they are expanding, because we have just pressed the gas in this cylinder in the liquefied form. That's why it is known as liquefied petroleum gas, LPG. Why? Because we have just compressed it and just pressed it, fill it in the container. So when the nozzle is pressed, the gas is coming out from this one, and this liquefied gas is converting into the gas. Liquid is converting into the gas because of expansion of the gas. You understood? So if I'm talking about that, if it is liquid, then in the liquid tanks, in the liquid tanks, that always the nozzles, for example, if you are having RO, you are very much familiar with the RO at your home. So RO tank have tap here. RO tank has tap here. This tank get filled and the water comes out from this tap. Why do the tap do not placed here at the top?
So
Oh,
since the bottom of the RO tank has higher pressure as compared to the top of the tank.
no, as the water levels comes down, okay, below the tap, you are not able to use that water, because liquid do not fill the container completely. Okay, as the levels down, if the tap is present here, you cannot reuse this water. But in case of gases fill the container completely. Gases are filling the container completely. So if you, in the cylinder, in the gas cylinder, that nozzles is present at the top. Because if you keep on removing the gas, still the gas will fill the container completely and will keep on coming, although unless and until all the gas comes out from it. Okay, understood?
Yes, sir.
Yes, sir.
So note it down. The particle in a gas are free to move in any direction. Just wait a minute. Okay, note it down after here.
Yes.
Done?
Yes, sir.
Yes, sir.
At this point also, the gases are the substance that don't have fixed volume and occupy the volume available to them. And it is the gas only that exert the pressure on the wall of the container. Okay, liquid do not exert the pressure. So note it down. Gas exert pressure on the wall of the container. Gas exert the pressure on the wall of the container. On the wall of the container. Done?
Yes, sir.
Yes, sir.
Noted, everyone?
Yes, sir.
Yes,
Write down
sir.
the topic: change in the state of matter. Change of state of matter. Change of state of matter. Change state of matter. Change in state of matter. As you know that if I'm changing, for example, if I'm having this vessel, okay, this vessel, and in this vessel, I'm just pouring some water. Do you know that if I start boiling this one, this is water, at what temperature with this water boils? This water will change into the gaseous state. At what temperature? Tell me, what is the boiling point of water?
Yes, sir. 100 degree.
You will say that it is 100 degrees Celsius or 373 Kelvin.
Yes, sir.
Okay. So at this temperature, the water start boiling. But if what I say that water will start boiling even if I'm keeping it at 20 degrees Celsius or 30 degrees Celsius. Is it possible the water will start boiling?
No, sir.
Yes, it will boil. Actually, what is the boiling phenomena refers to? Boiling means that this particle will start leaving the surface of this water and will convert into the gaseous state. Okay. What is preventing this water that it require 100-degree temperature to move this? Okay. So that is simply, if I'm going to explain you that this is the particles. Okay. This is the particles of water. Let's at the surface particles, and they are being attracted with the particle that are present at the below them. Okay. These are the particle and they are attracted below them. Okay. And sideways. So they are not leaving because the particles of matter attract each other. First property is this one. So that's why they require temperature. Second is that the atmospheric pressure. This is the atmospheric pressure that is exerting this over the surface of this liquids, that is preventing it to evaporate, okay, or to leave the surface. So it is the atmospheric pressure that is applied over here and it is preventing it to leave the surface. It is preventing it to leave the surface. Are you getting my point?
Yes, sir.
Yes.
So if I
Yes.
remove, in case if I remove the atmospheric pressure, okay, why the water boils at 100 degrees Celsius? Because we are boiling it in open air, and the water particles is overcoming the force. When we keep the water at 100 degrees Celsius, it can overcome the atmospheric pressure. I mean, the particles, the kinetic energy of the particles of water will become enough that it can repel or it can remove the atmospheric pressure. It will be equal to the atmospheric pressure. It can easily leave the surface. At 100 degrees Celsius, water particles have enough kinetic energy. So what if I remove the atmospheric pressure? If I remove the air over it, if I remove the